All right, a 20 kilogram box is pushed by a 100 Newton force directed at 30 degrees to the horizontal over a distance of 10 meters. You're going to be tempted to draw this as a downward force onto the box, like pushing a grocery cart or a lawnmower. But when you do that, that downward force is going to increase the force normal, because when you increase the downward force, you're going to increase the force normal, which would end up increasing the force of friction so much that the object wouldn't move. So when I did it that way, I realized that was wrong, so I switched it. So just through experience, I found that this is the better way to draw it for this particular question. The force is going up and to the right at 100 newtons, 30-degree angle, so the horizontal force is 100 cosine 30, or calculated as 86.603. Now that I've got that, I can start looking at questions a little bit and just see what's going on. I know my horizontal force, my vertical force up is 50, force gravity down 200, so if my push up is 50, and my force normal would then be 150 because 150 plus 50, 200 total up, and I've got 200 total down. Force normal is vertical. The displacement would be to the right. Those are perpendicular, so there's no work done by normal force. How much work is done by gravity? Gravity's down, displacement's to the right. Those are perpendicular, no work done by that force. How much work is done by the applied force? Well, work is force times displacement. The force is 86.603. They tell us the displacement is 10 meters. So we're just going to take that 86.6 multiplied by 10, and we'd get 866.03. Do you remember the unit for work? It's the same unit for energy, joules, capital J. How much work is done by friction? Well, the force of friction is coefficient. They tell us the coefficient is 0.5. So force of friction would be 0.5 times force normal of 150. So force of friction would be 75, coefficient times normal, 0.5 times 150. And that force of friction acted upon the object across the 10 meters of displacement. So 75 times 10. 75 times 10 would be 750 joules. Friction does act in the opposite direction of displacement, so the work would be negative. You can say that the force is in the negative direction and the displacement's in the positive direction, but since they oppose each other, it's negative. What is the work done by the net force acting on the object? Well, the net force, we have 86.6 going to the right. We have 75 going to the left. So the net force, when you subtract those, you should get about 11.603 as the net force. And then the work done by that net force, well, we've got a force. We just multiply it by the displacement of 10. And we would get 116.03 joules. How much work is required to move a 10 kilogram object from the ground to a height of 40 meters if it's moved at a constant velocity? In this case, I don't know that we're looking so much at force times displacement as work is also a change in energy. It's a change in gravitational potential energy in this case. So it didn't change velocities, it changed heights. So we have the mass of 10 times gravity of 10 times the height of 40. So the work then would be 4,000 joules. How much work does gravity do? Okay, well, we can look at it as gravity is mass times acceleration of gravity, Fg, and the displacement is the change in the height. So we would have Fg, or 10 times 10, 100, mass times acceleration of gravity, and then the displacement is 40. Again, the force of gravity is down, the displacement is up. They are in opposite directions, so they should have opposite signs. And then when you multiply them, you get a negative number, negative 4,000 joules. A block slides a certain distance down an incline. The work done by gravity is W. What's the work if it went same distance but the opposite direction? The opposite direction just means that force would now be opposing the displacement. So instead of being positive W, it's negative W. Mike is cutting the grass using human-powered lawnmower, pushes with a force of 45, directed 41 degrees below the horizontal direction. Calculate the work that Mike does on the mower pushing 9.1 meters across the yard. We need, in order for Mike's work, we need to know what the horizontal component of his push is. The horizontal component of his push is 45 cosine 41, which we got 33.962. That's the component of the force going horizontal. The displacement was how far? 9.1. So 33.962 times 9.1. Multiply those, we will get the work done by Mike. I know his push was with 45 newtons, but that entire push was not in line with his force, or in line with the, not parallel to the displacement. So this is one of those times where we can say work is force times displacement times cosine of theta. I just did the cosine of theta on my free body diagram. But if the answer is 309.054, then E would be 310. That's the best possible answer. Now we have Bill, a worker on a loading dock, moving a crate of mass 35 kilograms up a ramp that has a 25-degree angle. The height of the ramp is 5 meters, so we've made a little triangle on the side. 25 degrees, 5 meters. There's different ways to answer any of these questions, and I just kind of choose whichever one seems the most reasonable. If you see something easier, by all means, if you're getting the right answer, go for it. Here I can say that Bill is probably going to push this up at a constant velocity, so his force is going to be balanced with the component of gravity that's opposing him. I could also go with Bill is changing the gravitational potential of the object. And that seems easier, so let's go with he's changing the gravitational potential of the object. So changing gravitational potential energy would be mass times gravity times the change in height, 35 times 10 times 5, or 1,750 joules. How much work does gravity do? Well, gravity, the force of gravity would be, gravity is down, so 350, and the displacement was up, essentially 5 meters. So we could just go with negative 1750. But what if we looked at this and said, well, what component of gravity is parallel to the inclined plane, and how far does that act over it? Now, we should still get an answer that's really close to or exactly negative 1750, but what the hey, let's go for it. The component of gravity going down the inclined plane is mg sine of 25, and it's going to act along the length of this ramp. So starting with the force and calculating a value for the force, I got 147.916 newtons as the force. And if I was to figure out what is the hypotenuse of that triangle, well, I know the angle is 25. The opposite side is 5 meters. What is the hypotenuse? So what's the association to get the hypotenuse, the length of the hypotenuse, based on knowing the opposite side and the angle? Well, the sine of an angle is equal to the opposite over the hypotenuse. So if I want to know the displacement of that the gravity pulled, or the displacement that the gravity acted along the ramp, I could say the sine of 25 is equal to 5 over the length of the ramp. By just exchanging the L for sine of 25, multiply the L to the other side, divide sine of 25 to the other side, I get the length of the ramp is 5 divided by sine of 25. So the length of the ramp is 11.83 or 831 meters. Now that I know the component of gravity acting parallel to the displacement, I can do that math. Now they're in opposite directions, so it should be negative. And when I multiply negative 147.916 times 11.831, I get negative 1,749.994. Really close to that negative 1750 we were expecting. Don't forget that's in joules. All right, now we're still with Bill, and he's got his ramp, but now it's not frictionless anymore. It's got some friction to deal with. Still 25 degrees, still 5 meters tall, still a 35 kilogram crate, still traveling along an inclined plane that's like 11.831 or something like that. Just doing my free body diagram so I can have all my information in front of me before I start answering questions, simplifying the problem, taking the paragraph of explanation and turning into a diagram that I can understand. Of course, the dashed lines are just the components of the force that I've drawn. mg is straight down. There's a component of gravity that balances force normal. Component of gravity that goes down the inclined plane. If the object's going up the inclined plane, force of friction fights you by going down the inclined plane. How much force? Find the force that Bill applies to the box. We're going to assume balance forces. Bill's not going to be running up the inclined plane. Bill's an old guy. He doesn't want to have to do extra work. And realistically, it's more likely that you're walking up at a constant rate as you're pushing something up. So let's assume balance forces. So the force of friction down plus the component of gravity going down the inclined plane, those together add up to be the down the inclined plane force. So Bill will have to add those two together, and that will be his up the inclined plane force. So we're going to say the force of Bill is equal to friction plus mg sine theta. Force of friction is balanced with force normal times coefficient, so coefficient times mg cosine theta plus mg sine theta. Now we know what those numbers are. The coefficient of friction is 0.585. mg is 350 times cosine theta. Theta is 25. Plus mg sine theta, 350 times sine of 25. We add those two up by running the numbers through our calculator. Let's do the first number first. 0.585 times 350 equals that answer times the cosine of 25. I get 185.5667. I don't know why I did 4 decimals there. I've been trying to just do 3. Anyway, bonus decimal. Who cares? And then we're going to add that to the component of gravity, 147.916. Those two are the two forces going down the inclined plane. We're going to add those together to find out what the total down the inclined plane force is, and we'll know that that is Bill's force going up the inclined plane because he's going to make sure forces are balanced. He can walk at a nice, steady, comfortable pace. I get 333.483. And that should be newtons. I know that answer is written joules. I just got a little excited on that. Let's change number 6A, the units to newtons, because his force is in newtons. Sorry about that, guys. 6B, I'm going to take his force and multiply by the displacement. Let's look back to where I calculated it. I see down there it's 11.83 something, so 11.831. And that equals, because it's the same inclined plane as before, it just has friction on it. So same displacement. When we multiply these out, we can see how much work Bill is doing. $3,945.437 joules of work. Find the work done by the frictional force. Well, in Bill's calculation, I can see that the force of friction looks like is 185.5667. Now, the work of friction is going to be negative because it's in the opposite direction of the displacement. So we'll call the friction being negative and the displacement being positive. You can do vice versa, it doesn't matter. As long as your answer is negative. Displacement's up, friction's down, you get the idea. Friction's never going to add energy to your systems anyway. It's always going to take away. Let's get that math in, and we get friction is doing work of negative 2,195.443 joules. All right, number 7. New question, a block of 4 kilograms is pulled at a constant speed over a distance of 5 meters by a force of 8 newtons directed above, are directed at 15 degrees above the horizontal. Got my little picture going. Find the work done by the rope, on the rope, by the block. I think we've got some typos going on there. I'll fix that in just a second. But let's see, we've got our tension going up and to the right, 15 degrees. Horizontal would be 8 cosine 15. Vertical would be 8 sine 15. Force of gravity down, of course, being 40. I think if I scratch that out, it reads better. By the rope on the block. Yeah, that's much better. All right, 8 cosine 15, and then 8 sine 15. Find the work done by the rope. Well, it's being drugged to the right, so the force that's doing the work would be 8 cosine 15. Cosine because it's adjacent to the angle, and you set it up as hypotenuse function angle. So the work done by the rope, the force doing the work is 7.727. The displacement is 5 meters. And we're going to do force times displacement. 7.727 times 5 is equal to, let's put that through the calculator, 38.635 joules. Find the work done by the friction on the block. Well, force of friction would be equal to, well, yeah, constant speed, balanced forces. It's going to be the same value, but in the opposite direction. That's pretty cool. That was easy. We know force of friction is equal to the pull to the right because of those balanced forces. Find the work done by the normal force. Well, it's on a flat surface. Force normal is up, displacement's to the right, no work. Find the work done by gravity. Well, force of gravity is down, displacement's to the right. It's not on an inclined plane, so no work. Hey, number 8, we're on the last one. Yay! All right, we'll be done with this in like 6 minutes. A 100 kilogram block of ice slides down an incline that is 5 meters long and 3 meters tall. Someone pushes up on the block so it slides down the ramp at a constant speed. So in this case, you're not pushing it. Your push is against the direction of motion. The block wants to come down the hill. You're standing in front of it, kind of keeping it from going too fast, keeping it nice and slow. There is a coefficient of friction. So friction is going up the inclined plane. Your push is up the inclined plane. Gravity is down the inclined plane, and it is sliding down the inclined plane. So you've got the component of gravity, mg sine theta, going down the inclined plane in the direction of motion. Then you have your push and friction's push going against that motion, going up the inclined plane. Just about got my picture in place. Dashed lines, of course, are my components of the force of gravity in this case. The object is 100 kilograms, force of gravity is 1,000. I'm pushing up the hill, friction's up the hill, but the object is sliding at a constant velocity down the hill. So if we have the sine of theta is equal to the opposite over the adjacent, 3 meters over 5 meters, then we can say sine to the negative 1 times 3 over 5 will tell us what theta is. So on your calculator, if you're in degree mode, press the second button, the blue one at the top left corner, and then the sign that gets you sine to the negative 1 times 3/5. We get what theta, the angle is, 36.87 degrees. Now we know what our angle is. The horizontal component of gravity is 1,000 sine 36.87. I'm doing 3 decimal places and it comes out to be 600.001. I should round it just to 600, but I feel like since I've been doing 3 decimal places so much, I'll just keep with the 3 decimal places, but by all means, just round it and be easier. The vertical component of gravity is 1,000 cosine of 36.87. When I did that, I got 799.999 maybe. I should just call it 800, but out of some sickness, I'm not rounding. I'm going to leave the 3 decimal places. Force of friction is coefficient times force normal. Force normal is balanced with that vertical component of gravity. So force normal would be, let's call it 800 times the coefficient of 0.1. So our force of friction should be about 80, and I'm going to make it 79.999. All right, we have our force of friction. If the force of gravity going down the inclined plane is 600, if friction going up is 80, what's the force exerted by the person if we have to have balanced forces for the constant speed? Well, the force applied by the person plus friction is equal to that component of gravity, mg sine theta. So force by the person would be mg sine theta minus force of friction. In this case, it would be 600 minus 80 if we're rounding, or 600.001 minus 79.999. And when we subtract, we get 520.002 newtons because forces are measured in newtons. Find the work done by the person. Well, the work was done across a 5-meter span of area. So if they applied a 520 Newton force, we're going to take that 520 Newton force times 5 meters. So 1,100. No, 2,000. 2,600.01 joules. Find the work done by gravity. Well, the component of gravity is 600. It was acted upon across a 5-meter long span. So 600 times 5 is 3,000.005 joules. Find the work done by friction. So you can see which way this is going. Friction, the force of friction was 79.999. It acted upon across a 5-meter span. So let's take our 79.999 times 5. Should be just under 400. 399.995 joules. And it is negative because friction was going up the inclined plane. The object was moving down the inclined plane. Find the work done by the normal force. Force normal is going up to the left. The displacement is going down to the left. Those are 90 degrees, so there is 0 work done by